There's many types of reactions you can describe a reaction of having. There's four primary ones. We're going to talk about the four of them that you are responsible for in this class. There's two more that you should be responsible for, and that would be the combustion reaction and the redox reaction. But I'm going to talk about these four first. The first two are kind of opposite of each other. The first one is called the combination reaction, like we said in class, when two become one, or three or four, whatever, when they combine together to become one entity, we call that a combination. So we saw that in the class today when we saw magnesium plus oxygen making magnesium oxide, right? So that's a combination reaction. So A plus B becomes a compound that is made up of both components, A, B. We have A would be the magnesium, seen there, and B would be the oxygen. Right? They combine to form magnesium oxide. Right? Remember, we have to know what is the charge of these two things in order to write the correct formula. This is +2, this is -2, so one of each is needed for charge balance. So magnesium oxide looks like that. And if we really wanted to, we can also balance the equation here, but that's not really the point. But just to recognize that this is combining to form the thing that's called combination. The other one is the opposite, a decomposition. So one thing becomes multiple things is called decomposition. They have here something called mercury oxide, so HgO. Over time, it will bubble out the oxygen, leaving behind only the mercury. The bubble out is the oxygen that's bubbling out. See, A is Hg, B is oxygen, right? Mercury and oxygen is one thing, is one compound, but over time it breaks down to two different compounds. Not compound, but entity, right? This is going to just be mercury, which is a liquid, for example, and this is like oxygen, which is a gas. This one was a solid. So this solid breaks down into a liquid and gas component. If you really bounce it, it's already written in there, but you can also write it with the coefficients to balance it. Cool, does that make sense? The difference between combination and decomposition? So now let's talk about single displacement and double displacement. Another word for displacement you may see like in lab, they call it replacement. They mean the same thing. Okay, so in this, the formula is A plus BC equals AC plus B. Okay, so the general feel for this is there's always going to be there's two players basically on the reactant side. There's going to be a single person and a couple, happy couple. BC is happy couple. A single, not this happy single, but also wants to be with a couple, right? So A is going to go in and replace B, kicks B out. So B is now a single, and now A is the new partner of C. That's why we call it displacement or replacement. It's called single because we start out with a single entity first. Okay, now the partnership has to match. Cations will go with anions only. Okay, so let's say if A was a metal, BC, C would be a non-metal, right? I'm going to abbreviate that NM for non-metal, and B is the metal. So can A replace C and make AB? It cannot be metal-metal, right? The partnership does not work that way. Since this is the metal and this is the metal, a metal can replace one another. Okay, so for example, here we have zinc plus HCl. Okay, so what is your cation here? Is the hydrogen. What's your anion? Is the chloride, right? So zinc is your metal. So zinc, when it ionizes, becomes a cation. So cation will combine with anion. Right? So if I just give you this, you should be able to predict the product. If I tell you this is going to be a single displacement reaction, you say, okay, I have my metal, it's going to replace the cation. So what would that be? That would be zinc and chloride together. But however, remember, when we have an ionic compound, we have to write it with correct charge balance. Zinc is what charge? 2 plus. Chloride is what charge? -1. So in order to have charge balance, you need 2 on the chlorine side, 2 chlorides. Okay, and remember, this gets kicked out, right? Hydrogen gets kicked out. So it becomes by itself, but remember, hydrogen is a diatomic, so you just write a bottom subscript 2 there. And then we can also balance this out like we did in the lab, right? So there's 2 Cl and 2 H's over here, so we just put a 2 as a coefficient in the front. Questions? All right. The last one is the double replacement reaction. Just like the other reaction, we don't start out with a single. They are both paired up. Like going to a swingers club. They are both paired up and they're bored of each other. And I'm going to switch partners. Okay? So, A is your cation, B is your anion. So C is your cation and anion, C. Cation is always written in front. D is anion. So A will go with D. Does that make sense? And then B will go with C. So A becomes AD, CB. Why is the C written before the B? Cation's always written before the anion. Okay, so that's what a double replacement reaction looks like. Instead of having a single person first, you start out with both being couples. That's why it's double. So you get both ionic compounds at the end. So our prime example is sodium sulfate plus barium chloride. Okay, let's just say I didn't give you the product side. I did it in my notes, but let's say if I didn't, like on a test, wink, wink. If I say this and this, you add them together and you make a double displacement reaction. Predict the product. How do we do that? Then we say to yourself, okay, we have the first cation, it will combine with the other anion. What is the other anion? Cl. Just think about Cl. Don't say Cl2. Think about how sodium, what charge? Positive. Chloride, what charge? Together, they will form what ionic compound? Just NaCl, right? Because charge is already balanced. All right, so that's one of them. What's the other one? What's my other cation? Cation. Where's my cation? Barium. What's the charge of barium? Quickly look in your periodic table. Where is it? 2+. It's on the second column. Sulfate. Uh-oh. Did you memorize all your polyatomics yet? Sulfate is SO4, charge of 2-. So yeah, you have to memorize these polyatomics. So how many of each do I need? 1 of each. Good job, because it's already 2+ and 2-. They cancel each other already. So that's BaSO4. Questions so far? Let's do the counting. We have NaSO4. Remember when we do accounting, we just do it as a polyatomic. Ba and Cl. On the left-hand side, we have 2 sodiums, 1 sulfate, 1 barium, 2 chlorides. On the right-hand side, 1 sodium, 1 chloride, 1 barium, 1 sulfate. So what's not balanced? Yeah. Sodium and chloride. What do we put here? The coefficient should be 2, making sodium 2, making chloride 2. Okay, so that's what a double displacement reaction looks like. Now, one last thing we have to do is combustion. A combustion reaction is basically any reaction that involves carbon and you're burning it. It must have carbon and then you burn it. That's a combustion reaction, okay? More specifically, the products are carbon dioxide and water vapor. So let's say the one that we did in lab is when we burn methane, right? So methane has a formula of CH4. You burn it in oxygen to create CO2 plus H2O. This is the definition of a combustion reaction. A carbon-containing molecule burning in oxygen gives carbon dioxide and water vapor. Both of these are gases, so you can put states if you want, GG. This could be gas or liquid or solid, depending on how many carbons you have. And this is a gas. Okay? So combustion reactions are quite easy to recognize because it's very narrow definition. It has to have these four components, or else it's not a combustion reaction. Sometimes you will see plus delta also on the right-hand side. What is delta? Heat. So obviously when you burn something, the reason why you're burning it is because you want energy from it, right? When like gasoline, a candle, methane, they all release heat, okay? Okay, so that's how you recognize combustion reactions. Did I, in the lecture video, tell you how to balance these combustion reactions? They're a little bit trickier. So let's do them. CHO. How many carbons do I have on the left-hand side? How many hydrogen? How many oxygen? 2. On the right-hand side, how many carbon? 1. How many hydrogen? 2. How many oxygen? 3. But here's the trick. This is the trick to do combustion reaction. If you do this trick, it becomes a lot easier. Don't say 3. Say 2 plus 1. Go ahead and jot that down. 2 plus 1. Okay, and we'll see why in a bit. Everyone good so far about the counting? So we just go down the list. Is carbon happy? Pretty much happy. Is hydrogen happy? No. 4 here, 2 here. How do I make this to become a 4? So go over here. Where's hydrogen? Hydrogen's here, right? If it's 2, how do I make it become 4? You have to multiply it by 2. So you add the you add a 2 as a coefficient. So that makes this a 4, right? This is why we split this up. When there's a 2 as a coefficient here, this makes 2 oxygens, right? So that's why this becomes a 2. If you write it separately like this, it changes this number and not this number. It makes it easier to count. Everyone follow? Because that 2 coefficient only affects this oxygen, not this oxygen. So if you wrote 3 in the beginning, then you have to do mental math. This one is easier if you see it all laid out. Questions on that so far? Is everybody balanced yet? Who's not yet balanced now? 2 here and how many here? 4. So how do we balance out the oxygen? On the left, what do we do? 2 as the coefficient, very good. That makes this 4, because 4 is equal to 2 plus 2. Okay, so that's my trick to you when we do combustion reactions or any type of reactions really in the future if you take more chemistry. When you see an element that's appearing in multiple places, split them up in the numbers. Don't put as one number. Now, the exception is when it's a polyatomic. Remember when it's a polyatomic, we put the polyatomic, when we do the counting, just put them together. Because polyatomics don't split up. And then the last thing of the types of reaction is redox, but I talked, I think, extensively about redox in another video, so I'm not going to discuss it here. But redox is another type of reaction that you should be able to identify. And of course, a reaction can have multiple characteristics, okay? So for example, this can be called a combustion reaction, but you can also call it a redox reaction. Or a single replacement reaction, we can also call it a redox reaction, right? So it could be multiple qualifiers for one experiment, one reaction. Okay, so that's my lecture on types of reactions. Any questions? All right, good job, everybody.